Hey guys, what's up? Saga here, back with another develop video, and we're back again towards the quest of never-ending better flight. I'm working on the navigator again. This is because, well, last week has been very productive. I managed to implement crafting strategies, at least a couple of them, that should work, for anything that's not non-star. Sorry, that's not star. Managed to integrate the gathering logic back in, the grinding logic back in, and gathering normal nodes through the ground should be working, and I've been testing that all week. The stealth logic is back in, all of that, but I started yesterday to test the flight navigator with the gathering logic, and I noticed that in this area there's actually a lot of problems with the flight navigator. A couple of them is that the meshes that I extracted from this zone are not complete by any means. There's holes in the mountains, believe it or not. Like, there's most of the mountain, then there's a little hole somewhere. The navigator is thinking that it can actually go through the hole and come out through another hole near the node. There's missing objects, and the worst kind of problem is there are objects that are in the wrong position or the wrong rotation or the wrong scale, and that's causing more problems than anything else, to be honest. So I've been working again on the flight navigation. This time around I wanted to make it a little bit more precise, because one of the problems I was having was that due to the coarse way of representing obstacles, in some places, for example here, it would actually think that there are no escapes, that we are stuck inside a little cave, if you will, of obstacles. The same goes with the nodes. One of the problems was that the nodes are very close to the mountain, like say right here, right? So the node, and by that I mean the gathering nodes. So the gathering nodes, nav node would be considered an obstacle, but that's fine. I implemented it on like an autocorrect. The problem was that the autocorrect was using a node inside the mountain, because the real point is very close to the mountain. So to the autocorrect, picking this point or this point is the same, because inside the mountain there is no obstacles. The only obstacle is right here, right on the edge. So that was causing problems, but there is a solution for that, and it's what I started working yesterday night and all day today. And I'm ready to show you guys how the new navigator works. It's basically the same old navigator, but difference is that I'm representing obstacles in a different manner, a much more precise manner, because now a navigator node can actually be a partial obstacle, and it doesn't need to be a full obstacle or not, right? It doesn't have to be a yes or no answer. It can actually be a partial obstacle now. That's helping a lot. It's helping a lot with the precision of the flight. Another thing that I've implemented is that one of the things that was giving me problems was the new advanced raycaster that Ribbon Buddy uses doesn't actually detect some objects. So for example, this red roof, for whatever reason, the raycaster actually doesn't detect it. So the problem is that the navigator is going to go trying to go to a node where the red roof is, and the raycaster is going to tell it, yeah, it's clear, go ahead. But then it's going to smack its face against it, right? That's the only way to know right now, using Ribbon Buddy, if this red roof is there, is to smack your face against it. So I managed to implement some stuck logic that actually adds stuck points to the graph, and it's making it much better. It actually manages to get out of stuff like this, which I'm going to show you right now. So yes, the graphs changed. I have to remake them. This is going to take a little bit of time, but I'm thinking of skipping the extracted meshes altogether, to be honest, because they're giving me more problems than they're worth, I feel. Especially with the objects that are incomplete, with big holes, or objects that have the wrong rotation, translation, scaling, and all of that. They're giving me way too much problems. But I made the, you know, the the local raycaster much better right now. Let me show you that. Let's first use a graph. You can see here, the current graph is actually a little bit big, but this is a JSON file, right? The final graphs are going to be binary, compressed, and all that. Right now, I actually need to see what they are writing, so I made them JSON. Anyways, it's a little bit big because it's already meshed most of this area. So I'm going to show you how, once it has meshed most of the area, how it looks like. Let me show you that. Here's the thing though, right now I am not smoothing the path, and so it's going to look very cubic. It's going to look very VOT-ish. This is because I'm not applying any kind of path smoothing. This is because I want to first make sure the actual Pathfinder algorithm is correct and the obstacle detection algorithms are correct. Then I can worry about smoothing. So just be warned about that. It's going to look very VOT-ish, but the point is it's not going to get stuck anywhere. Well, almost anywhere. Let me show you that. Start. Alright. You can see that it goes right on the contour of the obstacles. Now those little stops, you can see that it goes around the trees. Those little stops it makes is when it detects mobs. So something I implemented now is that it'll go around mobs when possible. And yeah, this descent is not that good, but it's fine. You can see it reached the node. Once it's in a clear area like this one, it doesn't have much problems at all. Let me just leave it there for a second to show you how it looks. The gathering logic, you know, it'll stealth. You can actually see in the log why it's stealth. It'll tell you threat, Velodina, Sarconos, I don't know how to call that. It's because of this croc, basically. So it'll stealth near mobs. There are different ranges for different level differences between you and the mob. And you know, it's a little bit more involved this time around, all the stealth logic. And again, the flight navigator is going to try to go around mobs this time, like you saw right there. Try to avoid the Leshy. There's another Leshy here, which is why it's stealth. Let's just leave it there for a second to show you how it actually looks. Especially the flight navigation. You can see that it goes around obstacles fine. Yes, it looks VOT-ish again. I am not applying any path smoothing right now. First, I want to make sure that the obstacle detection, the raycaster, you know, all of that is working fine. Then I can worry about smoothing. Let's just leave it there for a few seconds here. So you can see it does that that very VOT-ish thing of going to the sides constantly. Again, that's because it's a cubic path and it's not smooth, but that's very easy to smooth out. I'll do that after this video. And you can see that there it actually went a little bit further up because of the threads down below. Let's see if I can show you that more clearly in another example right now. Definitely feels much better to start testing flight with actual gathering, you know? You can see it there, it went up, a little bit up. And goes to the node. So what I was saying is, it definitely feels a lot better to test flight with actual gathering because you can actually see all the different problems that it might bring you, like the nodes being right beside the mountain meshes. That was a big problem. It isn't a problem anymore with this new flight navigation. So let me show you just how much it can get out of tough places, right? let's go back to the starting position because there's a lot of obstacles there. Let's go actually inside this. This is a very difficult spot to get out of because the recaster in Ribbon Body doesn't detect that stuff up. You can see that it gets out. It starts flying towards the node. It detects the Leshy, tries to avoid it. Tries to avoid those two. Instead goes through all the obstacles and towards the node. Yeah, once in the node area, it's so open that it doesn't give much problems anymore. So let's go back here. Let's put ourselves in a difficult position to get out of. That's what I've been testing all morning. Because we can put ourselves here. This is actually a very difficult position to get out of by flying. And it got out. Let's try something else. So you can see that once it has meshed the zone, it can actually get out of very difficult positions. This is another difficult position, I guess. Yeah, it gets out, avoids the obstacles, goes to the node. Let's see, what other position can I guess? This one? Yeah, I haven't meshed this though, so that's going to take a while, but that's a good example of showing you how it actually meshes the zone when the Raycaster actually doesn't detect an object. Sorry, I'm a little bit sick today. Anyways, let's see that. That was easier than I thought. You can see that it stopped to Raycast there. It's stopping to Raycast here. This is a new path. It's never taken. Yeah, once it's meshed, there's no problem at all. And again, goes to the gathering spot. Let's go back. Right, so let me show you now how it looks like when the area is not actually meshed. So let's delete this and add a brand new mesh file for that area. So right now Elizabeth doesn't know anything about this area, nothing at all. So let me show you how that looks like. Let's start here in a not so difficult position, I guess. So Elizabeth doesn't know about any of these houses, nothing right now. This is going to stop and raycast a lot. You can see it doing it right now. It's starting to learn the area. Stops, raycasts. And those stops, you can see that those stops are very smooth, right? I mean, it doesn't actually collide with the meshes before it stops. And this is because the raycaster actually detects these objects correctly. The problem is when the ribbon body raycaster actually doesn't detect an object. So it smacks its face against the obstacle. But again, the logic I added for the anti-stuck stuff will actually mesh obstacles that that the raycaster doesn't detect, but you can't actually navigate through. So for example, this red thing, let me show you how that looks. Right, so there you go. You can see it's trying to go through. Look at the log though. It says we are stuck. So it meshes that obstacle. We are stuck again. Meshes the obstacle. We are stuck again. Tries another path. Meshes the obstacle. We are stuck again. We finally got out. And we go towards the node, right? Let me stop the thing here. Let's try that again. So you can see those objects are the ones that give problems because again, the raycaster doesn't detect them. So it has to actually smack its face against them to know that they are obstacles, but it learns from that too. So let's do it again. Yeah, trying there, stuck, can't do it. Look at the log. It tells you when it's stuck. There we go. This time it was smoother, but still tried to go through the obstacle. Let's try that again. Yep. And again, a new path never tried before. A new path stuck. Let's mesh it. We get out. Once more. You know, it's kind of like teaching a child how to do something. Again. Tries again another obstacle. No, can't do it. Another path. No, can't do it. I'm still stuck. Another one. No, still stuck. No, still stuck. The important part is that it actually gets out, right? It gets out eventually and picks a path to go towards the node. Yes, this time it's taking a longer path, but it'll get there. You can see it now. It'll get there. So let's try that once more. Now it should be smoother. Eventually it'll know the entire obstacle. Let's try it again. Yeah, this time you saw that. This time it didn't even have to get stuck against it. Now it knows it completely. Yeah, you can see how it learns. That's the basics of it. That even when the Raycaster fails, it'll learn from its mistakes, and it'll eventually get out and eventually reach its target. And next time it gets stuck in that obstacle, it won't be so clumsy and take so many tries to get out. And again, the power of crowdsourcing, right? All of these obstacles are getting sent to the server, so between every user, Lisbeth will just, know how to fly everywhere. And after a while, it's just going to be very smooth. But yeah, you can see that those are the hardest obstacles, to be honest. The ones that the Raycaster doesn't detect. Let's try it once more. Yep, this time around, it just went out. No need to smack our faces against the thing. Yep, trying this path. No, can't go there. It goes out. Once more. Yep, just goes out now. It knows that all of that is just an obstacle now. It really doesn't have any problems with it. You can see it there. It goes very close. Again, the movement is very cubic, but that's because there's absolutely no smoothing whatsoever. Tries to avoid the Leshy. Keeps. You can see it meshed the tree right there. Yeah, it gets to the node. Basically, this time around, the navigator is much more precise. You can see that it can get out of almost anything. And if it really can't get out of something, it'll just teleport out. Let's try another difficult position, I guess. This one's kind of difficult. More like this. Yeah, it gets out fairly easy. We are stuck. There we go. So yeah, this we are stuck logic that I made yesterday night has been working pretty well. That's this one. Yeah, that one was far too easy, I guess. It's taking a more difficult path this time around. You can see how it goes around everything. I guess that's a good example. This area is already meshed, so it just goes around. Yep, and towards the node. So anyways, guys, that's what I've been working on these past 2 days. I'll get the smoother in. I'll get the new meshes in. I'm going to mesh myself because, as you can see, it looks very botish the first few times when nothing is meshed. And I don't want you guys to get banned for using Lisbeth like this. So I'm gonna mesh around. Once that's done, I'll push the update with a new navigator. And yep, that's it, guys. See you next time.